Soccer players cover total distances ranging between 10 to 13 kilometres. Around 900 metres are travelled at high-speed running, which is speed ranging from 19.8 to 25 kilometres per hour. And 250 to 300 metres are covered by sprinting, which is speed above 25 kilometres per hour. Taken together, high-speed running and sprinting only account for 10% of the total distance covered during a match. However, these high-intensity efforts are considered of great importance for both competition outcomes and soccer-specific fitness testing. Straight sprinting has been identified as the single most frequent locomotive action in goal situations, performed by either the scoring player and the assisting one. High-speed running and sprinting distances also reduce towards the end of a game and temporarily after intense periods. These periods coincide with the last 10 to 15 minutes of each half, when higher frequency of goals are scored during a match. From a fitness testing perspective, the cumulative effects of physical efforts involving maximal or submaximal accelerations nearly reaching maximal individual speeds can lead to high internal load responses and cause detrimental byproducts. This is reflected by very high heart rates, for example, mean heart rates above 85% of maximal heart rate, increased blood lactate concentrations, and residual fatigue effects. High-speed running and sprinting distances exposure are critical training load components that practitioners should take into consideration and accurately manipulate with the aim to mitigate the likelihood of non-contact injuries. The article, published in the International Journal of Sports Medicine, titled Implementing High-Speed Running and Sprinting Training in Professional Soccer by Beato and colleagues, provides an overview of high-speed running and sprinting conditioning methodologies and monitoring strategies, as well as the recommendations for effective implementation of high-speed running and sprinting training for soccer players. This presentation, brought to you by Talking Sports Science, will provide a summary of the article. Starting off with high-speed running and sprinting conditioning methodologies in soccer. Common methods that aim to develop or maintain the ability to intermittently perform high-intensity efforts as frequently as required include high-intensity running and field-based drills that replicate actions of the match play. These training approaches and all-out sprinting or repeated sprinting formats, which comprise of linear sprint bouts of at least 40 metres, can be confidently used to ensure high-speed running and sprinting exposure. Another method used is ball drills in the form of medium and large-sided games, which prepare players to cope with the match demands. However, only few formats can be effectively implemented to develop high-speed running and sprinting capabilities, as playing rules, playing area, number of players, players' density, inclusion or exclusion of goalkeepers, and exercise rest ratios are all key aspects to consider when aiming to induce specific locomotor demands and associated physiological responses. In this context, efficient development and maintenance of high-speed running and sprinting capabilities can be attained by implementing the following game formats. Number 1. 1 versus 1 or 2 versus 2 formats with mini goals, i.e. 1.5 to 2 metres, played in either long narrow or long wide pitches with a low player density ranging between 200 to 300 metres squared per player. Number 2. Repetitive bouts, i.e. between 4 to 8 games of relatively short duration, i.e. 30 to 60 seconds, and recovery between 60 to 150 seconds, to ensure an exercise rest ratio ranging between 1 to 2 and 1.5. And the third recommendation is medium, i.e. 7 versus 7 and 8 versus 8, and large-sided games, i.e. 10 versus 10, of longer duration, for example above 4 minutes, played on pitches with a player density around 300 meters squared per player, allowed to cover similar high-speed running distances covered in a match. Playing matches is a critical component of the training process for achieving high-speed running and sprinting load. It should be noted that sole training sessions planned during a microcycle may fail to replicate the match equivalent of high-speed running and sprinting load. Therefore, depending on individual players' match time exposure, for example starters versus non-starters, it is recommended to implement different high-speed running and sprinting training methods in the days following a match. Alternatively, when feasible, during congested fixture periods, when time is limited, training sessions for non-starters could be implemented immediately after the match ends. Moving on to monitoring high-speed running and sprinting performance in soccer. Global navigation satellite systems, local positioning systems, and optical tracking systems can all be used to monitor high-speed running and sprinting performance. These systems extrapolate external load parameters such as displacement and velocity metrics over time. Analysis of high-speed running and sprinting are based upon the quantification of distances and relative time spent within speed zones. These speed zones are defined according to arbitrary threshold values or percentages relative to individual players' maximal speeds reached during either testing sessions or matches. Out of the three systems, global navigation satellite systems are sufficiently accurate to monitor distances during both high-intensity linear and sport-specific activities. Therefore, they can be used with confidence on a daily basis to make informed coaching decisions. However, there are a few things to highlight when monitoring high-speed running and sprinting. The agreement of high-speed running and sprinting velocity thresholds in soccer is still debated. The accuracy and variability of high-speed running and sprinting measures depends on the nature of the performed activities. High-speed running and sprint distances covered along fixed linear or slightly curvilinear locomotor paths can be confidently quantified. However, game-based conditioning such as small-sided games and possession drills that include frequent accelerations, decelerations and changes of direction may reduce the accuracy of external load quantification. Nevertheless, accuracy and reliability levels of global navigation satellite systems-based metrics fall within acceptable ranges. Typically, activities above or equal to 19.8 km per hour are interpreted as high-speed running, and activities above or equal to 25.2 km per hour are interpreted as sprinting. These fixed speed ranges are suitable for an overall quantification of the high-speed running and sprinting loads. However, their implementation as references for analysis of the individual exposure is still arguable. This is because general high-speed running and sprinting distance thresholds don't account for players' individual characteristics and fitness status, resulting in overestimated high-speed running exposure for some or underestimation for others. Absolute measures of distance covered, high-speed running and sprinting should be analysed as either fixed or rolling split times, namely epochs of 1 minute duration, in order to accurately capture the peak physical demands of match play and training sessions. Epochs of longer durations provide an overall quantification of intensity, but their use may result in cutting off and underestimating peak physical efforts, resulting in misinterpretation of the training stimuli and the associated responses. Based on the previous information, Marco Beato and colleagues offer 7 recommendations. Recommendation 1. Tracking systems and global navigation satellite systems can be used to monitor high-speed running and sprinting exposure based on fixed or individualized speed thresholds. Recommendation 2. A realistic quantification of an individual player's peak speed should be determined from either official matches or 30 to 40 meters maximal linear sprint efforts, or flying sprints, implemented as testing routine. Recommendation 3. Short sprinting distances, i.e. less than 30 meters, can be used to develop acceleration capabilities, but they are not suitable for sprinting exposure, i.e. distance covered at speeds greater than 25 km an hour. Recommendation 4. Medium and large sided gain formats can be used to ensure high-speed running and sprinting exposure, to ensure development and maintenance of high-intensity capabilities. However, field-based drills and sprint training may be preferable alternative methods due to their predictable high-speed running and sprinting exposure and the reduced variability in players' responses. Recommendation 6. Periodization of high-speed running and sprinting training should be based on starting status, i.e. starters versus non-starters, and match position demands, in order to optimize recovery and performance peaking for match day. And recommendation 7. Sprinting training may reduce the likelihood of lower limb muscle injuries, e.g. hamstrings, by exposing players to the mechanical loads and characteristics muscle actions required during the terminal swing phase of the sprinting gait. And that concludes the recommendations for implementing high-speed running and sprinting training in professional soccer. There is still much work to be done in the area, for example, investigating any advantage associated with the use of individualized speed thresholds determined from a player's peak speed compared to general thresholds, and the need for specific periodization guidelines to be produced to inform the design of critical variables for high-speed running and sprinting training, such as volume, frequency, density, and timing during the different phases of a soccer season. And that concludes this presentation. Thanks for listening, folks. See you next time.